Welcome to Learn Yourself. Today we are going to discuss about the preparation of hydrogen from acids and different alkali metals. These topics are under ICSE Standard 9 syllabus from the chapter Hydrogen. Earlier we have discussed the reaction of water with various metals and how we can produce hydrogen from them. Here we are going to discuss the preparation of hydrogen from acid. So we are going to discuss reaction with HCl, reaction with dilute H2SO4, and we will discuss that reaction with HNO3 is not possible and why. So first, magnesium metal, when it is reacting with hydrochloric acid, it will give us magnesium chloride and hydrogen gas. Now potassium, sodium, calcium, when they are reacting with dilute sulfuric acid, this reaction is not feasible. Why? Because this reaction is highly explosive. Earlier we have discussed that these metals are very reactive. So these reactions are vigorous. With potassium it is very vigorous, with sodium it is less vigorous, and with calcium it is least vigorous, but the reactions are explosive. So practically these reactions are not feasible. So magnesium will react with hydrochloric acid and will give us hydrogen gas. When zinc will react with dilute sulfuric acid, it will give us zinc sulfate and hydrogen gas. Magnesium, aluminium, zinc and iron will react with dilute sulfuric acid as well as dilute hydrochloric acid. They will give us hydrogen and forming its respective salt. Now what is the meaning of its respective salt? When zinc is reacting with H2SO4, from this hydrogen we are getting it here, but whatever another ion will be there, it is going to react with our metal and it will form a salt. So if this is HCl, then this Cl is going to react with zinc and we will get here zinc chloride, ZnCl2. So this is the meaning of respective salt. If it is H2SO4, then we will get zinc sulfate. If it is HCl, then we will get zinc chloride. Both are salt. Both are metal salt. So that's why we are saying here it's respective salt. Respective means if you are using HCl, you will get ZnCl2. If you are using H2SO4, we will get here ZnSO4. Next is when iron will react with HCl, we will get FeCl2, iron chloride and hydrogen gas. So here two reasons can be asked. That first reason is reaction with potassium, sodium and calcium are not practically feasible. Then we need to write that these reactions are very explosive. So that's why these reactions are not feasible. And second reason is when magnesium, aluminium and zinc are reacting with dilute sulfuric acid and dilute hydrochloric acid, they are forming hydrogen gas and respective salt. Then in that case we need to write one of this reaction and we have to explain that when they are reacting with H2SO4, it is giving ZnSO4 or MgSO4. When it is reacting with HCl, it will give us MgSO4 or MgCl2. That will come in that answer. Now we will discuss two important reasons that why we are not using nitric acid and why we are not using lead as a metal to produce hydrogen. So these two reasons we are going to discuss now. First reason is nitric acid, very dilute nitric acid. Also we are not using in preparation of hydrogen because nitric acid is powerful oxidizing agent. So whatever Nessel oxygen, now what is Nessel oxygen? Nessel oxygen is one oxygen. This is termed as Nessel oxygen. When oxygen is alone, it is not stable and it is very reactive. So it will always form a bond, a covalent bond with another oxygen, and it will form O2. But whenever the Nessel oxygen will be produced in the reaction, it is very reactive. So that Nessel oxygen is being produced in this reaction. So that Nessel oxygen will oxidize hydrogen into water. This hydrogen, when it is combined with oxygen, this is oxides of hydrogen. This is water molecule. It is also called oxide of hydrogen. So when it is going to attach with oxygen, this hydrogen is being oxidized here. So we will not get our desired product, and that is hydrogen molecule, but we will get oxide of hydrogen. Hydrogen will be oxidized in this reaction because Nessel oxygen is being produced with the use of when we are using nitric acid. So we are not using nitric acid in the preparation of hydrogen. This is the reason for that. But one exceptional case is when magnesium and manganese is there. When these two matter will be there, when we are using very dilute nitric acid, it will give us hydrogen gas. Why? Because this metal's reactivity is also low, and dilution of nitric acid will reduce the action of oxidizing agent. So that's why it will give us hydrogen gas. So this can be another reason that even though we are not using nitric acid in the preparation of hydrogen, manganese and magnesium can give hydrogen with the use of very dilute nitric acid. Then the answer can be that dilution of a nitric acid, that we are diluting it further and we are making it very dilute nitric acid. So the action of oxidizing agent will be reduced in this case. So it will give us hydrogen gas. Now the next reason is why we are not using lead as a metal in this preparation of hydrogen. So lead cannot be used in the preparation of hydrogen. So the answer is lead will react with dilute hydrochloric acid and dilute sulfuric acid, and it will form its respective salt. That means PbCl2 with hydrochloric acid and PbSO4 with sulfuric acid. And these salts are forming insoluble coating. This is important. They are forming insoluble coating. So that's why the further reaction will stop and further reaction is not possible. That's why it cannot give hydrogen, which is our desired product. So that's why we are not using lead, and we are also not using nitric acid in this preparation of hydrogen. Now we will see some reaction. It is with hot concentrated alkalis. So when some metals are reacting with hot concentrated alkalis, they will produce hydrogen gas. So let us study that. Hydrogen can also be produced with the help of hot concentrated alkalis. When zinc and lead will react with hot concentrated alkalis like NaOH and KOH. These both are alkalis. This is sodium hydroxide and this is potassium hydroxide. Then they are producing sodium zincate and potassium zincate, and our desired product. So zinc, when it is reacting with hot concentrated sodium hydroxide, it will give us sodium zincate. This is first is sodium, then it is zinc, and this is oxygen. So it is sodium zincate and hydrogen gas. When zinc is reacting with potassium hydroxide, it is giving us potassium zincate and hydrogen. When lead is reacting with hot concentrated alkalis, here the reaction with lead is possible. Then it will give us sodium plumbite. This is first, that is sodium, and this is plumbite, and hydrogen gas as our desired product. So this is how we can produce hydrogen gas from different acids and hot concentrated alkalis. Going forward, we are going to discuss a preparation of hydrogen via laboratory method. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.